It's Mrs. Woolley. I miss you all so much, and I am going to make this video about proportional and non-proportional linear relationships to help you solidify these concepts. Believe it or not, you have all the skills that you need to be successful on mastering these concepts. It's just the vocabulary that's probably giving you difficult, so let's go through it together. Okay, so we're going to look at a proportional example versus a non-proportional example. And I've organized some data in a table for us, and we're comparing time and distance to look for a relationship. So let's look at each column, looking at those finite differences. And as we go down comparing the data, we can see that we're increasing by 2. On the right-hand side for the distance, as we go down looking at those finite differences, we see it increasing by 6 units. So we'll look at that ratio, 6 to 2, and simplify it, 3 to 1, or just 3. So this represents a constant rate of change. So as soon as you hear constant rate of change, I know you're thinking slope. So our next step here is to represent this in an equation. So let's take our slope and multiply it by our time and compare it to our distance. So 3 times 0 is 0, which happens to be the distance. 3 times 2 is 6. 3 times 4 is 12, and 3 times 6 is 18. So it looks like we have our equation. If we let x represent our time and y our distance, we would take our time and multiply it by 3 to get the distance. So here our equation is y equals 3x. So far, you really haven't heard anything new. At this point, you're probably thinking, well, this looks like a direct variation. You're absolutely right. It is a direct variation. We can tell for a couple reasons. First of all, if we look at the table, we see right here, 0, 0. That's indicating that our y-intercept is 0. And if we plotted these 4 points, which I'll just do quickly, we can see that our equation would pass through the origin. Now, I can actually connect all this data, as you know, because this is continuous data. Now, the other really cool thing about this is we can start looking for a pattern horizontally. And we've been used to doing that vertically. So let's take a look at the data horizontally. So 0 divided by 0, that's really not going to help us very much. So let's not worry about that piece of data, but let's compare the ratio of 6 to 2. And, ooh, that's a nice trapezoid. And 12 to 4, and 18 to 6. And all of those ratios equal 3, which are equivalent to the slope. So right there we have the constant of variation, or the constant of proportionality. So we know that this is a direct variation equation. We also know that it's directly proportional. Well, these mean the same exact thing. If you have a special equation that passes, linear equation that passes through the origin, and you discover this constant of variation or constant of proportionality, which is the slope, you have a proportional relationship. I know the vocabulary seems a little challenging right now, but you'll get used to it. So basically, they mean the same exact thing. So let's take a look at our non-proportional linear function. So again, we're going to look at the data vertically, looking at those finite differences. And in the left-hand column, we see the same thing. We're increasing by 2. If we look at the right-hand column and compare the data, we can see this constant rate of 6. So if we simplify that ratio, 6 to 2 is equivalent to 3 to 1, or just 3. So we can see that our slope is equal to 3, same as the proportional data. So let's go ahead and try to write this equation. We're going to take our slope and multiply it by the time. So I'm just going to pull this up. 3 times 0 is 0, but we actually have an output of 4. 3 times 2 is 6, but we have an output of 10. 3 times 4 is 12, but we have an output of 16. And 3 times 6 is 18, but we have an output of 22. So we need to tweak our rule a bit. And here we go. I think if we add 4, we'll be all set. Let's just check that. 3 times 4 is 12, plus 4 is 16. 3 times 6 is 18, plus 4 is 22. And it checks on these first two pieces of data. So here is our equation that models this non-proportional linear function. So we can see that this starting value would be at 4 if we were to graph these ordered pairs. And again, we can go right connecting our points when we plot the data because this is continuous. So I'll start here at 4 and just kind of sketch it quickly. So this is a non-proportional linear relationship, and let's go ahead and try this sort of new idea as taking the ratio of the data. Of course, I don't want to take this first ratio because I don't want to divide by 0. But let's take a look at this one. Let's see, 10 divided by 2 is, you got it, 5. Again, we have that annoying little trapezoid. All right, and 16 divided by 4 is 4, and then I can see for sure that my data doesn't vary directly. So this is a non-proportional linear relationship. My y-intercept is something other than 0. I hope this helps. I'm really proud of you guys. Stick with it. I know you're going to make sense of it. I'm really proud of you. You're doing a great job. Thanks for listening and have a great day. Is she there?